Ready.
Okay, thank you. All protocols observed. Good morning, good afternoon, good evening from where you are joining us from. Distinguished guests, colleagues, ladies and gentlemen, my name is Engineer Lilian Kilatia, a civil engineer residing and working in Kenya. I am the chairperson of the WCCE Young Engineer Standing Committee, and we have organized this webinar so that we can be able to discuss the next frontier for civil engineers, which is a very important technological breakthrough. And on behalf of the WCCE Council and the President, who is present with us today, Engineer Oscar Sanchez, we welcome you to today's webinar. The webinar today is themed AI, the next frontier for civil engineers. I'm truly excited to see such enthusiastic gathering of engineers from across the globe, innovators and thought leaders from different sectors in civil engineering from around the globe to be able to participate in this discussion and also listen from the experts and see how we can be able to integrate AI in our day-to-day undertakings. At WCCE, maybe just to touch a little about who or what WCCE does. WCCE stands for the World Council of Civil Engineers. It is sorry about that. It is a global organization dedicated to advancing civil engineering practices and fostering collaboration among professionals worldwide in civil engineering sector. It was founded in 2005 and its headquarters is in Spain. And you can visit our website, www.wcce.biz, which is BIZ, to be able to learn more about WCCE and the different roles that it is undertaking to advance civil engineering in sustainable development and infrastructural resilience. AI is our subject matter this evening or this morning or afternoon, depending on where you're joining us from. And AI is transforming our world in a way that different sectors and different careers are actually adopting it for different uses. And for civil engineering sector, it is good for enhancing design, construction, and infrastructural resilience. And this session actually looks forward to appraising us on how we can explore the AI potential to shape the future of civil engineering and how we can integrate the AI in our various roles as civil engineers. I'd like to also welcome us to put any questions on the chat, but we'll also have an interactive session at the end, but you can put your questions on the Q&A chat as the presentation continues. And at this point, I'd like to welcome Professor Christopher Kipchumba, who is our speaker today, to be able to give his presentation on AI, the next frontier for civil engineers. Welcome, Professor Christopher Kipchumba. Professor, if you can hear me, please proceed.
Yes, I can hear you. I hope you can hear me well and you can see me.
Yes.
Thank you very much. WCCE, that is the new abbreviation I'm getting to learn, or I've been getting to learn about a few weeks ago. And I'm truly excited to join you this evening where we are in Kenya, and this morning for those of us who are away from Kenya. I'm excited because it is some of the work that we have been looking at of late and artificial intelligence in engineering is an area we have concentrated on for a few months, or if not a few years ago. Now, let me just introduce myself very quickly. Allow me to say all protocol of SAP, because I actually don't know who is here. So my name is Christopher Kipchumba Chepken. I am a professor of computer science at the University of Nairobi, School of Computing and Informatics for quite some time now, 20 years and 20 plus years. But currently, I'm serving as the Deputy Vice Chancellor at the Open University of Kenya. The Open University is the newest university in this country, for those of us who may not know. And it's a purely virtual university. It's a purely online university. And our learning programs take place on a robust learning management system. And you can learn from wherever you are, anytime, anywhere, and at your own pace, without necessarily being asked to be at somebody's speed. So today's lecture or talk is about artificial intelligence, the next frontier for civil engineers. We will unpack it as we proceed, but I will give you what I do understand. I do understand a lot of AI, but I may not understand a lot of civil engineering. And so what I'm saying here is I'll be talking a lot about AI and a little bit of application in civil engineering, because AI is not a single disciplined solution. It is a multidisciplinary solution. Now, let me move to the next. Okay, let me just confirm that my slides are moving. Yes, they are moving. So I'll start by a quick introduction. And I do know that many of us have heard about artificial intelligence, but we may not be knowing the standard definition of artificial intelligence, or even the theoretical principles of artificial intelligence. I think that is where the issue is. In knowing that it is artificial intelligence is different from knowing exactly what it is. What are the theoretical underpinnings of AI? So as we continue this lecture, I want you to ask yourself the following questions, and we can revisit them later on. What do you understand by artificial intelligence, or by AI as it is referred to generally out there? When did you start hearing a lot about artificial intelligence? As an engineer, you ask yourself, you may have heard about it maybe 10 years ago, 5 years ago, 3 years ago, but when did you start hearing about it? Then when did AI start concerning you? When did you start thinking about it? When did you, have you ever started thinking about using AI in some of the things that you do on a daily basis? I know engineers, they do design, structural drawings, and all those things that you guys do, predictions and so on. Others do, management of engineering processes. And I know you have different categories of engineers, highway, bridge, and the rest. But the question is, have you ever thought about AI and what you do on a daily basis, regardless of whether it's management, report writing, doing the actual design, the actual construction, and so on? And are you worried about AI? Is it something that is worrying you either in the negative or positive way? That is something that I would like you to, those are some of the questions I would like you to have at the back of your mind as we go through this lecture. Now, quick definition, but we are not going to dwell so much on the definition, but there's a point I want to drive home here. artificial intelligence is a discipline that it tries to create things. The keyword there are the artifacts. Artifacts are things, and I'm sure you know these things. The things like vehicles, the things like machines, things like any device, the things that you use at home, equipment, that have rational abilities associated with humans. So usually we define artificial intelligence as an intelligence which is not natural, which is the opposite of artificial. But it is not only defining as being intelligent. The question is, what is intelligent? Any being, any body, any artifact, anything will be declared as intelligent if it can perceive. Perceiving means even whether you see it or not, you can feel. You can have a feeling that it's cold, that it's hot, that it's dangerous, I need to move. There are things that you change in your life without necessarily being told or seeing anything. And then later on, you are told, why did you go that direction? Why did you come out of that vehicle? You say, I had a feeling, the feeling that something was not right. That is intelligence. Now, imagine building a machine that has that feeling, how difficult it is. In other words, you are going towards building a human being. Then these machines can reason and so on. These are definitions which were given way back in 1998. This does not mean that artificial intelligence started in 1998. It started way back, and I'll give you a little bit of history of when artificial intelligence started. Now, if you know the history of computing, and I am very sure you know, because as civil engineers, there was those few courses which you used to do, and I can attest to that. I was teaching some of the civil engineers way back in first year, second year. They used to do introduction to programming and so on. Now, if you did those courses, then you must have learned about the history of computing, and some of the things which arose at that time were computing was really propagated by the end of World War II, and the world was really made people start thinking. You know, there were many people who died, and many things happened. There were some machineries being developed, and people started thinking critically about machinery. And that is when computing started around from 1944 going forward. But then around 1950, some people thought that these machines look so intelligent, and it looks like we can make them. This might not intelligent, but these machines look like they can do many things beyond what humans can do. And so they started thinking about AI around 1950s by somebody called Alan Turing, who is said to be the father of this and computing in general. And he described the theories of AI and coined the term. So the description was, why can't we make machines which look like human beings? Then this guy said, the word is artificial intelligence. That was in 1956 in a certain conference. Point number one to the civil engineers, you cannot avoid congregations. You cannot avoid conferences. You cannot avoid workshops if you want to progress in your area of specialization. This and many other examples show you what people do in conferences and workshops. They come up with things way back in 1956. Quickly, around between 1970 and 1980, nothing really happened. There were people who are saying, no, artificial intelligence machines cannot be intelligent, blah, blah, things like those. And so between 1970 and 80 something, towards 1990, there was nothing happening. But some big companies like IBM then was one of the biggest companies. It was actually the biggest in technology, if you think about it. And it was working behind the scenes, just like these other big giants now, like Google, are working behind the scenes, Microsoft and the rest are working behind the scenes, and soon you will see things coming up. And they came up with an algorithm that time that would play chess with individuals, and they came up with what you call IBM's Deep Blue chess champion, who actually played chess with the world chess champion human being, and was actually able to beat that champion. That is when now artificial intelligence came in again, and around 2010s, deep learning and big data analytics and algorithms that analyze data and got intelligent output out of it came in. Things like speech recognition, computer vision, and so on came in around 2010s. And recently now, things have changed. We have what we call generative AI. So the things that you call ChatGPT, DeepSeek, Copilot, and all those things that you hear are called generative AIs. And I will talk a little bit about how they are built as we go forward. There are various areas of application of artificial intelligence, but the same model applies. It is basically about how you use the data in that area. So if you think about health, for example, and you think about something like AI-assisted surgery or diagnosis, it is all about having a machine or an algorithm here that has been trained, and the keyword there is training. Of course, it's been built, and then it's now being trained with data, diagnosis data. And this data looks something like, there were cases, there are 10 million cases. And nowadays, the generative AIs we are talking about are looking at billions of cases. So there are billions of cases of individuals who had these symptoms, and eventually it turned out that they were suffering from this. Now, an artificial intelligence algorithm that does diagnosis can be able to literally diagnose everything. If you imagine having 10 billion cases. And this is a machine, so it can analyze very quickly. Within the shortest time, it's able to go through all those records and make some conclusion. It is not rule-based. Rule-based is some kind of an AI algorithm which says, if it is dark and there are a lot of clouds, then the answer is that it's going to rain. If the guy is tall and is handsome and is from this region, then chances are that he is going to be from this tribe. Those are rule-based. Generative AIs, machine learning algorithms are not rule-based. They are algorithms that are able to generalize, analyze extensively, and adjusting its knowledge appropriately. So there are various areas of applications of artificial intelligence as listed there. Again, I've shared the slides. They are not copyrighted. Of course, you don't copy paste directly, but you can look at them later on because of time. Now, what are the areas of AI in engineering? So if you look at these other areas, energy, agriculture, and so on, they are all related to engineering. I think I was trying to figure out what is not engineering here. Because if you think of health, for example, maybe the least application areas, but there are, engineers who are dealing with machines here. There are engineers who are dealing with construction of, health hazard management system within the health industry and so on. So first of all, what I wanted to say is that AI is applicable to all facets of engineering. All. Because engineering is applicable to all facets of life or all areas of problem solving. So some examples, AI can be used in construction and structural monitoring. That I am very sure you know, but for what? As I said, I know that there are various engineers at different levels. So there are those who are practicing hard skills of engineering, just like we do in computing. There are some of us who are practicing hard skills of computing, that is systems analysis, design, programming, deployment of system, configuration of systems, networks, databases, designs, and so on. The same thing with engineering. So it depends on which area you are at the moment. So if you think about engineering in general, that is the first diagram on top here. You would think of AI as a simulation machine. You want to know, and I know a little bit of engineering, I don't know engineering. That is the point I'm trying to make. If you want to know how the structure of a certain building should look like, given that, of course, there are theories, there are standard structural knowledge which you guys have at your fingertip, having learned these things in school and practiced. But then sometimes you get to some situations where you are not very sure because of the land terrain, because of the unpredictability of the environment, the weather, the climate change, for example. Let me use climate change because none of us knows what Nairobi will look like in the next 50 years. Now, it is up to you as an engineer to get climate data so that you can simulate how the drainage system of Nairobi will look like in the next 50 years, given the data that you have had for a very long time. And then be able to then design something that will withstand that climatic conditions in the next 50, 100 years. So you can simulate for the next 10 years, 20 years, 50 years, and so on. There are AI tools that are at play when it comes to simulation. You can do design optimization. I know in engineering also there's something called over design and sometimes under design. I have had an engineer come and look at some of the structures and say, this thing is over designed. Why are you putting this number of steel or this size of steel on something that is just going one floor? I've even seen an engineer say, I didn't put any steel on my house and it's one-story building. There's no need. Now, there are AI tools which help you understand that kind of environment. And if you are doubting as an engineer, then you can say to an AI tool, give it all sorts of things that you have around, and they should be able to give you an optimized kind of design. There are many things I could talk about, but I just want to, I'm just joking your mind. It's a 30 minutes talk, so there's nothing that really we can go into details. If you think of AI autonomous construction machines, which people are now threatening you guys in your construction industry, that in the next few years, we will not be having these guys who jump into lorries in the morning to go for construction site. It might just be that there's an engineer in some office somewhere ordering machines to do things, and they do it with precision. It's coming. So in AI, in civil engineering, mostly it is transportation networks, predictions, and things like those. Site monitoring, for example, you don't need to be going to site every now and then. Structural analysis, checking whether what you have provided as a structural design of a certain building is adequate if you are not sure. I'm sure you do agree with me that you do work in a certain area, you do understand your area, but once in a while you get a job that really challenges you, like, hey, I've not done this before. I don't know who has done this before, but I have to do it. AI is your friend now in this part of town and the rest of the world. So AI can also be used for infrastructure maintenance, predictive maintenance of roads, bridges, and dams. And this is also related to climate. I want to emphasize on climate resilient infrastructure, because to be in a position to have that kind of infrastructure that can be resilient to climatic conditions in the next 20, 30, 40, 80 years, you really have to have a way of predicting these climatic conditions and the way the area will be, so that you are in a position to do designs which can last for decades. Otherwise, you will design tomorrow, and then maybe in the next 5 years, you just have to bring it down. So these AI tools are important. Also, it reduces the cost, because imagine you don't know how the future will be. What that means is maybe you will over-design, or you will, I don't know, most likely you will over-design because you are fearing. Then it is 100 years and the thing is just the way it is. Most buildings, by the way, were over-designed in most parts of the world that did construction long time ago. Image recognition for crack detection in pavements, traffic pattern analysis and optimization. Those are some of the things you can pursue or look into later on, or in future, if we have another time, we can still come back for a deeper descriptions of how then to use these tools, which we are talking about. But for now, it is basically just giving you just a taste of the things that are on the table for you. And many of these things are all over the internet. The issue is just putting them into perspective. Now, what are these AI tools? Let me start by saying this. As well, the discipline which we are in, which is computer science, we learn how to build these AI tools. We also learn how to train them and validate them, and also how to use them. Chances are that at the engineering level, you may not come to the level of building this, but you'll come to the level of training, validating, and then using. So many of these tools you see here, and I'm sure many of you have seen many of this or some of this, are available for tailor making for your use, but you must have the data to train. And you must train it in such a way that you know what you are going to use it for. So a couple of this, we know, of course, the Open AI, which is the ChatGPT, which is one tool that claims to do many things. That is the American one. The Chinese DeepSeek is the competitor, or rather the rival to ChatGPT, which is open by OpenAI company. And they do very many things. What I want you to do is just to go at your own time. If you go to the website and say ChatGPT or DeepSeek, and then when it gives you the interface, you just ask it, hello, what do you do? And it should be able to list for you all the things that it can do. So those are generative AI tools, and there are many. So there is one for free pick, the one for analyzing images, checking images. Like, for example, if you got somebody having your images somewhere, then you can ask some of these generative AI tools to check whether they are actually legitimate images of you, or somebody just recreated them. There are a number of this. There's a Gemini. Gemini is a Google. Nowadays, you see when you Google something, the first set of results is results from an AI tool by Google, which they have integrated on their website. and it checks. So it doesn't search the web, as it were. What it does is that it uses the data which it's been trained on. And if it doesn't find, then it now goes to search the web. So it can scroll the web on real-time basis and give you those results. What can you do with these tools? It depends on what they do, but most of them do very many things. Draw diagrams, teach you, guide you. I mean, do structural drawings for you and so. There are a number of civil engineering AI tools which I came across. Some of them are not seen. Some of them are seen earlier when you are preparing other lectures. There's one we call civils.ai. And it is one of those document kind of management AI system for engineering. And mostly it manages things like tender documents, proposal bids related to engineering, site investigations, codes of practice, optimized drawings, data sheets. You guys understand these things. That is one AI. It is a proprietary, meaning you need to buy it. But once you buy, you can train it with your own local data, and it should be able to do quite a lot of this. There are other AI tools. Again, I don't want to go through each one of this, but what I want to bring to your attention is that there are a couple of AI tools for engineers already, specifically for civil engineers in this case. And the question is, how do you use these tools? And as I said, chances are that you don't want anybody to be seeing your data, so you need to customize them and bring them into a secure server, probably within your institution or a privately owned server, which you can then put your data there and continuously train your AI. It is possible to train your AI to a point where you tell it, if you are an engineer who has been doing structural drawings for 50 years and you've been keeping this data inside there, it is possible to then ask that AI tool to design for you a two-story building with your data. Let's say you have been keeping the data there and religiously training this model. Then it can do it in 2 minutes and it will be perfect, because generative AIs depend on the data that you put in. So there is a word which usually use, cabbage in, cabbage out. So this AI tools, or generative AI tools, are trained through a process called prompting. So most of the focus in civil engineering and other engineering related disciplines have been on design and construction, safety and sustainability, so that you have robots doing things which humans cannot do because of safety, site monitoring, so that you are able to know who is on site, who is not on site, work progress, and things like those ones. Like safety, check whether there are people who are stealing stuff and so on and so forth. But there's another aspect which is called prompt engineering in generative AI systems. And basically what prompting means is that you are trying, in layman's language, you're trying to make an AI tool better for your own use. You're trying to contextualize it. So it is the art of crafting effective prompts, and prompts are very basically like commands or questions. It is a command to do something. And this is used to guide large language models, which we call generative AIs, to generate or to produce desired outputs. Now, and I'll show you a little bit of what that means in the following slides. But generally what it means is that you are fine-tuning your models for specific tasks, ensuring they deliver accurate and relevant results. So that when you say draw for me this, then you will have told it over a long period of time. So it's teaching. Let me end this description by saying it is basically teaching. This tool. Now, you will not dispute the fact that this thing is intelligent, because anything that is intelligent can be taught. You know very well your animals, even at home or wherever it is. The people that you have, the first time you meet them, they are you might call them dumb, or you call them they don't know anything. But wait until you train them. Wait until you tell them do this, and then they do it wrongly, and then you say no, this is not how it's done. It's done this way. Then the next time they will do it. So that is the way prompting happens. So in one of the generative AIs, I tried to do some prompts. And this I will use to just explain to you. I said, you are tasked with designing a two-level building in a coastal area. Can you provide the guidelines? And this is what it gave me. So the red one is what I wrote, and the black ones is what it gave me. So it said you need to do site assessment and planning. You need to do foundation design. You need to do structural considerations, material selection, building envelope, which is basically how the cover will be, and so on, environmental and sustainability features, regulatory compliance, occupant safety and access. Now, why is it even bringing occupant safety and access? It is basically in a coastal area. So here, there are things which are likely to happen, like environmental features. Sometimes the ocean is very, rough, and therefore you need to take into consideration that. Then after it gave me those guidelines, I told it, draw for me a diagram. So this one, the red one, is the prompt. I said, draw a diagram. And this is what it drew for me. Two-level house, but it also gave me the guidelines. This is how they look like. They are exactly like what they are here, but I said draw a diagram that demonstrates what you have said. Now, the thing is, the next point I want to make is this. They become better as you prompt them. Look at this. I said, draw for me a structural diagram for two-story house. And it says, I can absolutely help generate a structural drawing for a two-story house. Before I do, could you please provide a few important details to tailor to your needs? And it says the details look something like this. It says, I need the size, I need the layout, I need the roof type, I need the foundation material. Now, I say this, in this red, this is what I gave it. Now, what am I doing? I'm trying to make it better. Next time I give it this one only, it will suspect that this is the kind of house I want, because it will have captured this on the database. I will have made it better. So that is what we call prompt AI engineering for this particular case. And there is prompt for any other discipline. So I said, draw for me a structural drawing for two-story house with the following details. Size and dimension, total floor area is this, with 5 bedrooms, each with a bathroom. It should also have a kitchen and a living room. Layout preference should be that ground floor, has the living room, kitchen, dining, blah, blah, blah. And this is what it drew for me. Now, I looked at this building and I'm not seeing the kitchen. So I said, draw for me. I didn't say draw for me. I just said, I'm not seeing the kitchen, living room and dining. That's what I typed. I didn't tell it that in the drawing, I am not seeing the kitchen. And I didn't say redraw it. I just said I'm not seeing the kitchen and the living. And it says, you're right, the previous diagram focused more on structural layout and room leveling, but missed clearly showing the kitchen, living room, and blah, blah, blah. I will now regenerate a structural layout diagram that includes the ground floor, blah, blah. It describes it, and this is what it drew for me. Never mind that it has put things in places where I didn't say. I don't think I said I needed a balcony somewhere, or maybe I did, but that is what it brought. Now, and I said again, convert it to a structural design and have only ground floor and first floor. Make it 4 bedrooms. That is the structural design it gave me. What am I trying to explain to you? We don't have enough data on these generative AI systems that can actually, or rather that has been used to fine-tune these generative AI systems. If you want to use them, this is the second point. I've only made 2 points. This is the second. If you want to use these tools, you must understand the training concepts of these tools. And you must have the right data to train these tools with, so that they can give you good results. Under that point again, these things cannot be relied on 100%. You have to still have your engineering skills at play. So there are various opportunities of usage of AI in civil engineering. There is design and planning, there is construction, there is maintenance and operations. And I am very sure you guys as engineers can associate with this. So AI can generate multiple design options considering various constraints and criteria. You can say, give me descriptions of 3 types of design for a 2-bedroom house in XYZ towns. If people have been using AI in that town, or if you have been training it, it should be able to give you like 3 proper designs which you can choose from, and you say to a client, which one do you want? There are a couple of challenges, and this is where I will, I think we're almost the time is almost coming to an end. So I'll go through this very quickly because I want to make my last point. There are challenges in adopting AI. Number 1 is infrastructure and cost. Infrastructure, these algorithms run on very powerful machines, infrastructure, memory, data, movement from one point to another. For you to say, draw for me a structure, for somebody, you will send us text. Going through the bandwidth to where the server is okay as text. When it is being sent to you, where you are seated from the server to your machine, it is sent as an image or a video, because you can say, create for me a video. Now that requires proper sets of infrastructure. Storage. You know how many people are drawing on that database? How much space does it need? That infrastructure requires a lot of power, cooling power. Cost comes in. Data privacy and security concerns. So this data, these things you keep putting every day. Write about me. Who am I? Give me a bio. Then it says, I don't know you. Then you start describing yourself. How secure is your data? Then there is inadequate training and resistance by users and algorithmic bias due to bias training and dependency on technology. I highlighted those 2 red ones because they are the core. That is my last point. You guys, as users of technology, and particularly moving towards AI now, the biggest challenge is lack of training and resistance by users, but more importantly is what we call algorithmic bias towards biased training data. You won't get. So I want to end by saying there are only 2 reasons why we're still lacking behind when it comes to applying AI in our various disciplines, and in this context, civil engineer. We focus too much on use rather than on building and training the machines. We need to think about building our own machines, our own tailored machines. And when I say machines here, I mean the algorithms. I mean the artificial intelligence algorithms, which the general description are machines, because then if it is a machine that is intelligent enough to know that something is falling and therefore it should cover other delegate machines, then at the end of the day, you'll have to have a brain for it. That is the one we are talking about building here. The other mechanical developments will be done by other people, you know, the motors and the others. But the brain to control those mechanical components will largely be built by computer scientists. And you know, these computer scientists just know algorithms. It requires the user, in this case, who is an engineer, to guide on how to build this thing. We're still avoiding these things rather than embracing. And I think in academics, where I've been for some time, the biggest challenge we have now is how do we ensure that our examinations are authentic, that people are not writing theses using AI. And I've been telling people, there is nothing you can do about it. People can write their thesis using AI. I think you should, so my philosophy nowadays is emphasize on the solution of the problem. Because look at it this way, if you have a tractor for plowing your land and you don't know how to drive the tractor, then the tractor will be useless. So learn how to use it and use it efficiently, but also concentrate on the problem solved, not on how to do it. Because if this guy can write a thesis that without assuming that maybe all of us have written thesis, a thesis is something that is a story that makes sense. It is something that when read, it should convince someone, regardless of whether you are there or regardless of whether you understand the discipline or not most of the time. That's why it's called a thesis. It is a story that you must build to be able to convince people. You cannot build a story that convinces people if you don't have facts. Any other story without facts are just fictitious things. That is why we have storybooks, we have, you know, fiction writings and all those things, newspaper reportings, cuttings, opinions, and those are not theses. A thesis is something that is built on factual. Now, if somebody can do that by using AI, it means they can do it on their own. That I can tell you, because the focus is on problem solution. The last thing is bias due to the training data of the algorithms. We do not have our own data, and therefore anything that you ask the AIs which we have, they will always be based on the data from the West most of the time, and the East, depending on where the algorithm is coming from. Our data is unclean. Unclean in that we are not systematic. I once said that if you are a 50-year-old engineer who has been doing your designs and you have been keeping them religiously and you trained your model, then you don't need to be drawing anymore. You just need to be asking it to do it for you, and it should be able to learn through it. We haven't reached that point. The challenge to me, or rather the challenge to you guys, is think about the training, think about creating your own data, think about cleaning your data, think about understanding the current algorithms and how you utilize them. That would be the end of my presentation, but I want to just bring to your attention one thing, which you will have a look at your own time. Artificial intelligence and responsible computing. What is responsible computing? What is responsible artificial intelligence? Because artificial intelligence is one of those tools which can bring unethical practices and even human rights violation activities when you are using. Be careful not to put yourself in trouble by using AI in ways that can harm other people, that can make other people disadvantaged, that can disclose other people's data, and make sure that you use AI responsibly. There are many ways in which it can harm other people. And there are examples of non-responsible AI, discrimination. Let me give you one example. If you used AI today in Kenya, an AI tool trained in the West to analyze the behavior of inmates for purposes of releasing them on presidential pardons, like the way we have in Kenya. If you use one that has been trained in the Western world, you wouldn't get anyone released in Kenya. Because the training data there talks about things like, if you're white and you had a job and your family members are doing well, then, and you have been in prison for 2 years and you have not committed any discipline, then you can be released. First of all, how many white inmates are in Kenya? That means it won't work. That is discrimination already. So before you use any AI tool, be careful that it is not going to do any harm to anybody, and it's going to be fair and so. And you can think about very many unethical uses of AI. Finally, ladies and gentlemen, I want to say thank you very much. And I keep having a saying which says it is one thing to have talent, it is another for that talent to be noticed. It is yet another to be given a chance to utilize that chance. So there are two things. You need to notice talent and you need to utilize that, or rather give an opportunity for someone. If you want to build someone, I think once you notice they have a talent, you need to give them a chance to use that talent. Just noticing talent is not enough. It is better to give somebody an opportunity. And I am saying that because I want to thank you for inviting me to give you this lecture. Thank you very much. Over to you.
Thank you, Prof. I think that was quite insightful. And I think we have gained a few insights and also knowledge with regards to AI. We also know a few tools that we can actually be able to harness to be able to be more productive and also integrate AI. Now, I'm seeing a question on the Q&A from Engineer Matalanga. Engineer Matalanga is asking, what informs AI? Sometimes AI gives the wrong answers, and one has to have sufficient knowledge and experience to fully benefit from AI tools. Maybe,
Okay.
Professor, you
Yes.
can be able to couple that with, you mentioned something on the AI training data and the biases, and also depending on models that have been made or curated by others, especially in other continents. Maybe my question would be, how can one enhance that AI training data?
Okay. Very well. Thank you very much. The first question, first of all, let's all acknowledge that AI is a creation of a human being. And let's look at it this way. If you, as a human being, can still get wrong answers, and then you are creating a machine to give answers, then it means it can even be more wrong than you are. So that's number one. The question then was, how come it gives these wrong answers? It goes back, it's the same question you're asking. It is the data that you have. Sometimes it is the way the algorithm is built. If it's not well built, well designed, then sometimes it misses some things. And there is sometimes something called ambiguity in data. So if you have, okay, let me give this example. You know, generative AI tools, they keep storing the data that you just gave it. And when they are solving your next problem, problem number 2, they will look at your first problem first to check whether they are related. And let me give you an example. If you tell it, I will be giving a lecture to WCCE this evening, what do you think I should tell them? They're likely to say, that is a very good lecture to the women congregation of something, CDE, something, education. Then you say, no, it is not women, it is civil engineers. And then he says, oh, yes. Now, what does it learn from you? So it has tagged you, you have an ID, then it tags the WCCE, and then it tags the things you're asking. So next time you use WCCE, even if you mean women, then it will not go to women. It will have known that you and WCCE are related. So it will give you answers in that direction. Now, what has happened? It means you have not given it the right questions. You have not prompted it correctly. You have not learned how to do prompt engineering. So there are several reasons why to give you a wrong answer. Number 1 is you have not prompted it well. You need to tell it, I'll be giving a lecture to, I keep forgetting the name of the organization. I don't know what W means, but I know they have a civil engineers something. So it will know that that is the one you are talking about if you give it in full the first time, and it will associate it with you. If you don't do it, then it can give you wrong answer. So ambiguous prompting. Number 2, the data. The people who have been using this model again might have been asking things along those lines. So it assumes, or they might have fed it the wrong data. So let me give you another example. Let's say we have this model which we use to request for designs from it. And we have been feeding in data, the designs which we have been doing for the last 20 years. Some guy might put in a wrongly designed structure. And then in your query, you are actually telling AI to give you a design which actually looks similar to what somebody had done before, but it is wrong. So it will retrieve for you that one because it matches your description. But then it was wrong initially. So the data was wrong initially. And context matters also. That is the third reason. You might be asking for this question, for these things when you are in Europe. It is not the same when you are asking in Africa. Contexts are different. So there are several reasons, but the most important one is data. You have well trained the model, then it will give you mostly the accuracy. That is why there is no such thing as right or wrong in this case. There is the accuracy level. So we rely on the accuracy level. We say a scale of 1 to 10, if you get 9, you're good. If you get less than 7, then maybe you should not use it. And you know what? Humans are not as accurate as we think. The things that we usually say we are accurate about them, I can assure you, you are engineers, but I can assure you that humans are not accurate. Because if they were accurate, we would have finished everything. How come there has been 1G, 2G, 3G, 4G, 5G in terms of telecommunications? It's because somebody realized that from 2G, you can fine tune some things and you get to the next level. And the same thing with machines. I hope I've answered that using a lot of words, but it's work in progress.
Yes, thank you, Prof. I think that was a good response. Unless Engineer Matalanga is not satisfied or has a part B of the question, we'll proceed to the next question from Sanchez Munyasa. He's asking, hi, how do engineers pivot on this age of AI, IoT, and big data to not be left behind? Majority are still in denial despite the immense potential to upskill. How do we inculcate it in the engineering coursework? Prof?
Okay, that is very simple. It is to have, and I am happy that, contrary to a few years ago, you would go to a forum of engineers and you find old people. I'm happy that there are now young people who are willing to try things. The easiest way is to influence curriculum. And I have said this even in my university. I've said professors should resign or retire at the age of 55. This thing of going to 70 years is not helpful. Because you delay creativity if you occupy an office for a long time. So anyway, that's a philosophical one. To answer your question, the easiest way in influence curriculum development, as Association of Engineers across the world, particularly in Kenya, get to the engineering schools where you came from, influence curriculum design. That way, that is the only way. And of course, when you're practicing out there, try to make people understand that these tools are useful. Thank you.
Thank you, Prof. We'll just take one more question, then we bring the session to a close. And I see the question has been posted on the chat by Mureithi. Is it Mureithi? Let me think it. Oh, yeah. As a young engineer and an AI fanatic, I am intrigued by how AI can be trained by ordinary users. Sometimes the AI platform may not remember your previous information if you start a new chat, thus losing the context. I have seen such challenges with Gemini and AI. That makes training to be fixed on a single long chat, which may be improbable with some AI tools. Can this be addressed?
Yes, can easily be addressed. These charts, these tools we are using, we should know where to use them from. If you want to use these tools professionally, you have to build them, or rather you have to install them in-house. In-house, once you install them in-house, they are configured to understand that your uses are contextual, and they will not be picking anything. Number two, make sure you log in to these tools with your accounts all the time. Register so that you're logging, so that every time you log in, they know it's you. The things you are doing yesterday will not disappear. Chances, I am not sure, but chances are that the engineer here keeps using just on the face without necessarily logging in, because then it will forget you. It doesn't keep the knowledge. Now, the other part is, I think, is a comment intrigued by how AI can be trained by ordinary users. That is okay. However, I can tell you this, and this is a question. Let me turn this question the other way around. This question would have sounded like, is there a chance that everybody will be an engineer and they are likely to steal our jobs or make us useless? That that question is one of the most ridiculous ones that any person does. Your business is not how to do it. Your business is what to do. If you know what to do, then how to do it is not a problem. That is why you guys don't do the masonry. You know what needs to be done. You don't do the stealing itself. You know that this structure must be reinforced this way and this way and this way, but you don't do it. There's somebody who does it. So what is your problem? If you know the kind of structure that needs to be drawn, and you know the theory behind it, and then you just have some guy, some clerical person, do the training for you using the data you've provided and the knowledge for you, and do the engineering. The engineering is not in how to do it. The engineering is in what to do. So the point is, don't be intrigued. It is the order of the day. It is a lawyer, you know, people train lawyers. People actually, you know, if you know your rights and you're going to court, you can actually have a locally trained AI tool in this country and tell it, write for me a defense, 10 pages of defense. And these are the things that happen. Give it verbatim of the statement that have been written by everybody in that case and say, give me a defense. That does not make you a lawyer. That and nobody will believe you can write such defense, but you have done it. Now the question is, the question is this: if you are not a lawyer, the reading might sound very melodic, but it may not defend you, because you might not be knowing the actual interpretation of the law that this tool has used as your defense. So you might actually incriminate yourself. So why do you need a lawyer? Because lawyers understand the law. They know what it is. But how it's done is how they do it in court. You see, different lawyers do it differently. Some of them don't even quote the law. They just go and intimidate some people there, and then people see like you have a lot of points, and so they do factual defense without going the law, because they are trained. They know what it is to be a lawyer. For you, you know maybe how to do defense. So in this case, I think this is Duncan Morithi. That should not worry you. That should worry you. What should worry you is avoid being general, because then the AI will also be general because it doesn't really know you. The reason why it asks you to log in is so that it can create a portfolio for you. Thank you.
So thank you, Prof. I believe you have sufficiently tackled the questions, and also the contents of the presentation were well understood. And from what I have been able to hear is that one, we have to log in so that we can train the AI to have a model that will be able to undertake the tasks that we are supposed to undertake as a civil engineer. And once you log in again, it will have that memory. Then the other thing is that we have to be open-minded to AI and be willing to be trained on how to use AI. And here is where prompting becomes a critical issue because how you prompt the AI determines what kind of output you will have. The other issues are on data security and ethics, and I think this might be tackled globally through perhaps policy development and implementations. So it's good to appreciate that AI is the AI tools are here to stay, and the choice about how we get to deploy the AI tools is actually ours. And we can actually use it to optimize the civil engineering output. So thank you very much, Professor Kipchumba, for taking your time to be able to give us this talk. Just to remind the presenters and the attendees that WCCE stands for World Council of Civil Engineers. Our website is www.wcce.biz. You can be able to look up the website and be able to get more information with regards to what WCCE is and what WCCE does. But generally, its mandate is to advocate for civil engineers and enhance their roles through advancing the civil engineering practice and fostering collaboration among professionals worldwide. So this is a worldwide organization, professional organization that brings civil engineers together. Thank you so much, Professor Kipchumba, for your presentation. I'd like to also thank the President, Engineer Oscar Sanchez, who has been with us and has been very active on the chat and the Q&A. Thank you very much, President and Council members. I also like to recognize the President-elect, that is Engineer Nathaniel Matalanga, and other council members in attendance. Thank you so much for making time and also facilitating or approving for this particular webinar to be done. To the attendees, this could not have been possible without your enthusiasm and your attendance and willingness to be able to learn more about AI and how we can integrate this in our daily roles and tasks. So I believe we have already been converted and we are going to see how to integrate the AI tools in our daily undertakings. To the Secretariat, which is the Colegio de Ingenieros Civiles, I hope I'm pronouncing it right, Caro. Thank you so much for your support to undertake this webinar and also for engaging on the chats. We ask and continue and encourage continuous collaboration between the Open University of Kenya, Professor, and WCCE, and also the Secretariat continuous support and the Council at WCCE to the Young Engineer Standing Committee webinars and other activities. So you can also follow the World Council of Civil Engineers, Young Engineers Forum on X and also on LinkedIn to be able to follow on this and many more activities to come. With that, I'd like to call it an evening unless President, you'd like to close our session, Engineer Oscar.
Okay, thank you. Thank you, Lily. And thank you, Professor Kipchumba. It's a pleasure to have you here. And for this topic of great relevance. So thank you all the participants for joining us in this morning, afternoon. And we hope we'll attend the next webinar that we will take in the next month. Thank you, all of you. And thank you, especially Lily, for support us. And of course, to Professor Kipchumba. Have a nice day.
Thank you.
Thank you so much. May leave now at our pleasure. Good morning, good afternoon, good evening, good night. Bye.
Bye-bye.